Here's problem 2919. An electron moves through a velocity selector, electric field equal to 4 kilovolts per meter, magnetic field 2 millitesla, subsequently follows a circular path, radius 4 millimeters, in a uniform magnetic field. What is the magnitude of this magnetic field? Okay, so if we go through a velocity selector with an electron, say moving with some velocity v, if we had a magnetic field, say coming out of the page in this selector, then there will be a magnetic force on the electron equal to QVB sine 90 degrees going up. And if we had an electric field in the opposite direction, or top to bottom, there will be an electric force on this electron equal to QE going down. If the electron survives the velocity selector, it must be true that these two forces are equal and opposite. So QVB is equal to QE. Charges cancel out, and solving for the velocity, we get it's equal to the electric field divided by the magnetic field. And in this case, that would be equal to 4,000 volts per meter over 3 millitesla, 2 millitesla. And that is equal to 2 times 10 to the 6 meters per second. So that's the velocity of the electrons when they enter the new region. Now in the new region we may have a new magnetic field, and most likely we do. So when the electrons start moving in a circle, the radius of that circle is related to this magnetic field. Since the centripetal force of that circle is provided by the magnetic force, it should be true that QVB is equal to mv squared over r. And so if we solve this for r, getting rid of one of the v's, we have r is equal to the momentum divided by q times b. Nice to know. That's the radius in general. But in this case we want to find the magnetic field. So the new magnetic field is going to equal the momentum divided by q times r. In this case it's going to be the mass of the electron, 9.11 times 10 to the minus 31, times the velocity, 2 times 10 to the 6 out of the velocity selector, over the charge of the electron, 1.6 times 10 to the minus 19. Even though it's negative, we just want to find the magnitude of this magnetic field. And the radius of the orbit is 4 millimeters, 4 times 10 to the minus 3. So this is 2.85 times 10 to the minus 3 Tesla. That's a magnetic field that the electron enters and then starts moving in a circle within. 2.85 millitesla is the answer.